Hello everyone, welcome to my YouTube channel today. So I had already talked to us about types of leukemia, which I thought I should give you guys a picture presentation, and that I have done looking at types of acute or types of myeloid leukemia. So today I thought we should look at types of lymphoid leukemia. Before we continue, my name is Dr. Emmanuel Ogbodo. I am a lecturer in biomedical science, and I'm also a biomedical science here in the United Kingdom. So yeah, let's get into this. I had mentioned to us that in leukemia, because it's important when you go for a biomedical scientist interview that you acquaint yourself with what is likely that you might see, or in the implication of what that is being presented to you or asked you when it comes to blood film morphology. So I started telling you guys that in blood cells you have a stem cell, and this stem cell can renew itself. Okay, you can see it can renew itself. For example, it can renew itself, or it can differentiate into two lineage. And this lineage is where you can talk about either myeloid or lymphoid. So we had already talked about the myeloid stem cell type of leukemia. So that is where I told you that under the myeloid, you can get other blood cells apart from lymphocyte. Now, what I had told you guys already was that you can see from this myeloid, you can see this megakaryoblast. So when you say megakaryoblast, it means that you are referring to leukemia associated with what? Platelets or thrombocyte. Because you can see from megakaryocyte, you can get megakaryoblast, you can get megakaryocyte, and you can get platelet. Both megakaryocyte is still an immature platelet. Megakaryoblast, like I've told you guys, is a blast cells that will further differentiate if everything is normal to what? Platelet. Now, if you see a blast cells that can further differentiate into mature erythrocyte, you can call it pro-erythroblast. Then if you see the blast cells that can differentiate further to maybe basophils or neutrophils or eosinophils, you call them myeloblast. Then if you see blast cells that can further differentiate into monocytes, you call it monoblast. Now, hopefully this will make sense what I was trying to say, on my previous video regarding types of myeloid leukemia. So this makes sense why we can say something like maybe acute megakaryoblast leukemia, or you can say something like acute myeloblastic leukemia or acute monoblastic leukemia. So I had already explained all of that on my previous video, but I still want to highlight that the types of leukemia you are talking about, once you know it is from myeloid, you then need to ask yourself, is it referring to this lineage or this lineage or this lineage or that lineage? But that has been explained. So today we are going to focus on the lymphoid stem cells. So you can go for an interview and they present a blood film, leukemic blood film that is coming from the lymphoid. So lymphoid, from the word lymphoid, you can actually liken it to what? Lymphocyte. So from the lymphoid stem cell, you can also get, you see that word again, come again, blast, lymphoblast. So it's a blast cells that can differentiate further and become matured lymphocyte. I think for this presentation, I wouldn't want you to worry so much about T lymphocyte or B lymphocyte, okay? So what I want you to focus on is the lymphocyte matured or are they immature? So when they are immature, there is something wrong. Then of course, when they are matured, it's very, very important. So that's what I thought I should give us as a background, okay? So we are going to focus only on this lineage, which is lymphoblast. And what I tend to show you is some blood film presentation, so that when you go for interview, they ask what are the types of maybe lymphoid leukemia. You can mention a lot of things which I'm going to be showing you, and of course which I have already highlighted on the previous video. Right, let's still look at this. Once again, I'm not going to focus on the myeloblast, okay? So we're going to focus on the lympho stem cell. So you can see again the lymphoblast. Now, why I present this is because of these plasma cells, okay? So when you hear plasma cells, is coming from the lineage of the lymphocyte or from the lymphoid. Does that make sense? So it is important that you note that plasma cells refer to lymphoid lineage. We are going to discuss that further, but I thought I should show you that because that was not highlighted on the previous slide. Now let's go into the main thing that I want to show. So I want to focus on pictures, okay? On pictures, because when I mentioned it, somebody just put a comment saying, you know, when I talk about the types of leukemia, somebody highlighted that it would be good that if I show you guys the pictures, and that is why I want to show you the pictures. I hope that makes sense, okay? Now let's look at this. This is example of acute lymphoblastic leukemia. Now I want you to start bringing everything that I've taught you, you know, in the past. Now for the fact you hear the word acute, what it means, remember I told you that acute talk about high number of blood cells, maybe 30% more than, you know, blood cells, as the case may be. So that talks about acute. When we talk about chronic, you can get maybe less than 20%, or in some cases, like I've mentioned, less than 30%. Now, but for the fact you've heard the word acute, it means that the blood cells, the immature cells, are very high. Does that make sense? So for the fact you're saying acute lymphoblastic, so meaning that you are talking about blast cells, lymphoid blast cells, acute lymphoblastic. So lympho means lymphocyte, blastic blast cells. So it means that the blast cells you are seeing is from the lymphoid. So that's why you call it acute lymphoblastic leukemia, and that is what you call your, in short form, ALL. Now, why do we use the word acute? Because most of the things you are seeing here, they are blast cells. All of these things you are seeing here, they are blast cells. Okay, so and one of the things that you can see in acute lymphoblastic leukemia, like I've already mentioned, you are going to see immature lymphocytes. So the immature lymphocyte here is going to be more predominantly, mostly they are going to be what? They are mostly going to be blast cells. Okay. Now you're also going to see that if you look at it, because they are blast cells, you can see that the nucleus, okay, is large, leaving small portion of cytoplasm. So you can see that cytoplasms are not much when you compare with that the size of the nucleus. Okay, now that is what I mean by scant cytoplasm. Okay, now you're also going to see that it has large nuclei, which is this. You can see that the nuclei cover the main areas of the cells, and of course if you look at inside it, I'm not sure if you can see this very clearly, you can see there's some kind of opening, depending on if you can see very well. Like if you see this, there's some kind of opening, okay, like this. I think this highlights it more. There's some kind of opening here, so that is a nucleoli, so it contains nucleoli. So one of the things you're going to notice when it comes to blast cells, that they are likely to cover most areas of the cells. Does that make sense? Leaving a scant cytoplasm. Why this is correct, but sometimes it will require experience. It may vary depending on the cells that you are looking at. Sometimes it may not necessarily going to be so, but in most cases that is what you are likely to see. So when you see most of this blood film like this that is mainly blast, it means that this type of leukemia is acute lymphoblastic leukemia. Why? Because the cells appear lymphocytic, and the cells are what? Are blast cells, and they are lymphocytic blast cells. So that's why you call it acute lymphoblastic leukemia. Okay? Now, if that is clear, let's go to the next one. So another type of the lymphoid leukemia is what we call prolymphocytic leukemia. Now, from what I've told you guys in the past, if you say pro, it means before. So prolymphocytic leukemia means actually the stage before the formation of what? Lymphocyte. So prolymphocytic leukemia, which is generally known as PLL. So now again, it contains numerous prolymphocytes, which is what you can see here. So these are mainly prolymphocytes. Okay, so this is not a prolymphocyte, by the way. This is not a prolymphocyte. This is not a prolymphocyte. This is a typical way you can see prolymphocyte. Look at it. Okay, so what happens? The nucleus tend to be a little bit should I say a little bit that you are going to see more cytoplasm than when you compare about the blast cell. Okay, so you are going to see numerous prolymphocytes, which is example is this. Okay, now more than 55% lymphocyte. There are still going to be some lymphocytes, okay, but they are also going to be what? Pro lymphocytes, like I've shown you. So these are lymphocytes. Okay, these are lymphocytes. Okay, these are not pro-lymphocyte. This is example of what? Pro-lymphocyte. Okay, so that's what you're going to get. Now, another feature that can help you is that they have a prominent central nucleus. So if you see that this is a nucleus, this is a nucleus, then if you look inside this, you're going to see a nucleus there, which is typical with what? Pro-lymphocytic leukemia. That's pro-lymphocyte. Does that make sense? When we say pro-lymphocytic leukemia, we're basically talking about pro-lymphocyte. Okay, so that is a type of the leukemia. I hope this is making sense. So I'm trying to present you guys pictures. So when you go for interview, they say, what do you think you can see? Or even if they ask you generally, what are the types of leukemia? Maybe what are the type of lymphoid leukemia? Or what are the type of acute lymphocytic leukemia? Or chronic lymphocytic leukemia? Whichever thing that they've asked, I'd already mentioned this, you can be able to give these examples. And of course, if they present you a blood film, you can be able to actually, if you have the confidence to say, this is the type of the leukemia, not just saying it's a lymphocytic leukemia, you can have confidence to say, this is pro-lymphocytic leukemia. You can actually say, this is acute pro-lymphocytic leukemia or chronic pro-lymphocytic leukemia, depending on the confidence you have. But the principle remains the same as I'm trying to show you here. Okay, now let's look at another one, which is also acute lymphocytic leukemia. Okay, acute lymphocytic leukemia. Just because I mentioned T and T, so the T here talks about T lymphocyte. It's talk about whether it is T lymphocytic leukemia or T lymphoblastic lymphoma, as the case may be. But again, what I want you to know is that if you look at this from what I've already said before, you're going to see there's no more cytoplasm. So again, these are blast cells. I just thought I should put this. Okay, these are blast cells, and because they are mostly blast cells, they are acute lymphoblastic leukemia. But because it is associated with the T cells, okay, or maybe in a case of lymphoma, okay, you can see this maybe in lymphoma or just in leukemia. So as the case may be, so this is a typical example of acute lymphoblastic leukemia or acute lymphoblastic lymphoma. Does that make sense? Okay, so even the T there talks about the T lymphocyte. But again, I want you to see, without even thinking too much about it, you can see the nucleus here. Then you can see that the cytoplasm, there's no more cytoplasm. The areas are covered by the nucleus. Okay, and that means that this is a blast cells. Okay, I'm just saying that these blast cells could be leukemia or lymphoma. Okay. Now, let's look at another one, which is also one of the common questions they may ask you, is what we call chronic lymphocytic leukemia. Again, because I've said chronic, it means then there's not going to be blast cells. If there is, it's going to be less percentage, like less 20% or less 30%. Now, if you look at it, these are all lymphocytes. You can see that, okay? This one resembles a little bit of pro-lymphocyte, okay? But the rest are mostly lymphocytes. Does that make sense? Now, this is example of chronic lymphocytic leukemia because there's no blast cells here, if that makes sense. If there is, it's going to be very little. But I just thought I should show you that in chronic, you are likely to see mature cells, but they are going to be many. They are going to be numerous. Okay? Now, let me also show you something else that can be unique. Something else that can be unique with what? Chronic lymphocytic leukemia, and this is what we call smudge cells, or you can just call it smear cells. Okay, so these smear cells, okay, are typical for what? Chronic lymphocytic leukemia. Because with the chronic lymphocytic leukemia, because of the nature of the condition, kind of disrupts the cytoplasm of that cells. So once you make a blood film, it's going to kind of squash that very cells, and it can present these very smear cells or smudge cells. So these are a typical example of what? Chronic lymphocytic leukemia. Now, what I want you to understand is this: if you see any smear cells, don't think anything far from chronic lymphocytic leukemia. I just put SLL here because I want to just refer to small lymphocytic lymphoma. So if you see some of the lymphoma or lymphocytes, when they become too small, as the case may be, or when they become small, this can also be associated with the lymphoma, and that can be called small lymphocytic lymphoma. But the point I want to make is the fact that this is chronic lymphocytic leukemia in a case of these very small cells. That is what I think you should be expecting if you do go for interview. I hope this is making sense. Okay. Now let's look at another type of lymphoid leukemia, which can be generally when we talk about myeloma. Okay, so when you say myeloma, you are referring to, that's why I showed you guys about the plasma cells that is from the lymphoid lineage. So now if you say myeloma, you are talking about plasma cells. Is mainly mainly plasma cells. And because a plasma cell which is, associated with myeloma, okay. Now, so these are plasma cells. So they are known as, these are associated with myeloma. And these plasma cells help in the making of antibodies, okay. Remember that when we talk about the lymphocyte, you are referring to adaptive immune system where, of course, the antibody, the memory cells are being produced. Now, let me give you an example. So when we talk about, I'm going to show you more about plasma cells are things like this, okay? Things like this. You can see where the cytoplasm, the nucleus come a little bit forward. It comes forward, okay, and give a certain kind of this round shape, okay? So once you see this nucleus here, a little bit tiny comes forward, okay, and give it a certain shape. That is called plasma cells. So these are plasma cells. Now, let me give you another example that can make it clearer. In the case of multiple myeloma. So in multiple myeloma, you are going to see a lot of the plasma cells. So these are examples of the plasma cell. You can't miss it. Once you see it like this, you know that you are talking about plasma cells. Look at that nucleus. Look at this. Look at it. Just a tiny nucleus out here. Leading to high, space of what? Cytoplasm. There's a lot of cytoplasm, but a little nucleus pushing forward. So once you see that, you are referring, that is plasma cells, and you start thinking about what? Myeloma. Okay? When it is multiple myeloma, you are going to have, significant amount of these very cells. Does that make sense? Okay? So this is also another type of lymphoid leukemia. Remember, we're still talking about types of lymphoid leukemia. Okay? Now, let us look at lymphoma. So if you have known about myeloma, which I've told you is in the bone marrow, is produced in the bone marrow, in lymphoma, it developed from the word lymphocyte, okay? Now, again, if you look at this, what do you think is going on here? Don't forget what I've said. You can see that the nucleus here covers the major areas of the cells. There is a tiny cytoplasm in most of the cells here. Obviously, these are blood cells. Does that make sense? Okay? But if you look at this, you can see some features which I have already mentioned here that can show you that this is not just a case of maybe immature lymphocyte, although it's immature lymphocyte. But when you see some of the features that I'm going to mention in addition, okay, to what I've already said, that the nucleus covers the majority of the cells, you are going to see that this is talking about lymphoma. For example, the shape of the nucleus is variable. You're going to see that the shape of the nucleus appear variables. They are not just the same. Okay, they appear variable. Like if you look at example like things like this. Okay, things like this. Okay, things like this. It's not variable. It's variable. It's not as smooth as you can see in other one where it is just round shape. Does that make sense? So again, you can see that nuclear chromatin is less condensed and some small nucleoli are visible. So you can see that some of the small nucleoli here can be visible, okay, as shown with the red arrows here. If you can see it, red arrows. So they are visible. And again, the presence of Botox cells are shown in the with the blue arrow. So you can see these Botox cells here, okay, Botox cells here. But the point I want you to, they give away here, which is what I'm going to suggest to you, is the irregular shape of the nucleus. This look like a kind of acute lymphoblastic leukemia, but in acute lymphoblastic leukemia, you are likely to get the nucleus to be, the nucleus to maybe to be regular. But when it comes to lymphoma, it's not going to be regular. There's going to be irregular shape, okay? And of course, you are going to see that the chromatin is going to be less condensed, unlike that of the acute lymphoblastic leukemia. Anyway, this is called lymphoma, okay, which is also another type of lymphoid leukemia, okay? So now let us look at another type of lymphoma, which is very rare, okay, but you can see what we call Hodgkin lymphoma. The only thing I can say about this Hodgkin lymphoma is these very Stemberg cells you can see here. So once you see the Stemberg cells, you can see there are some plasma cells here. Don't forget, there are some plasma cells here. Now, because you can see these plasma cells, okay, now you can see the Stemberg cells is a giveaway to know you are looking at Hodgkin lymphoma. So I just decided to put it here again. It can be developed from the lymphatic system, okay? But once you see the Stemberg cells like this, okay, which has two nucleus, by the way, okay? So you have, you see, there's one nucleus, there's another nucleus. Once you see that it's called Stemberg cell, just know that you are referring to what? Hodgkin lymphoma. Again, this is another type of lymphoid leukemia. Now, I think this should be the final one where you look at the hairy cells, still the lymphocytes, okay? But you can see it has some hairs, okay? So once you see these hairy cells, they are called hairy cell leukemia, which can be commonly anyway with lymphoid leukemia. I hope I've been able to make this very clear. Yeah, thank you so much for listening. Let me know what you think about the video. So I think at this point, I've been able to give you guys overview of the types of leukemia, whether from the myeloid or from the lymphoid. What I would suggest is that you should go and listen to types of leukemia, types of myeloid leukemia, and of course this one, types of lymphoid leukemia. Then try to put them together. Of course, link it to the my previous video on the blood film morphology, and if you can actually look at full blood count validation result video that I made, that would also help you to give you overview picture of what I'm trying to communicate when it comes to types of leukemia. Thank you so much for listening, and please can I ask you to like, share, and subscribe. Thank you till I come back your way again. Bye bye.